Okay, there we go. That's better. Hopefully that's a better description. Should reference N64 instead of NES. Welcome everybody. So this is the first stream of my N64 efforts. And as I mentioned yesterday to those of you who were there, hi Lila, speaking of, my basic plan here is to start with the RDP because I think there's basically two things that are particularly challenging about N64 emulation, and one of them is the RDP, and one of them is the interaction between the CPU and the RSP. And so the RDP is like a more separable problem. It can be worked on in isolation more easily, and so I want to start with that, and plus I just want to learn about 3D rendering. So the plan that I have, and you can see this is the MooPen 64 source code, is that basically I'm going to patch MooPen to dump the RDP command lists to a file, and then I can use that as the source for my RDP renderer efforts. And so hopefully that'll give us a nice something to play with as we get started, and then eventually we'll probably turn this into a real RDP plugin that MooPen can run, but that's a little farther down the road. So without further ado, that's where we're going to start, and it should be pretty easy to do, I think. What is the RDP? Oh yeah, good point. So the N64 has, actually let me see if I can find a good diagram real quick. 64 block diagram. But basically the N64 has two major components, and then one of those two splits further. There we go, that'll work. Okay, so the N64 has two main components. There's the CPU, which is a MIPS VR4300, pretty much stock, and then the reality coprocessor, which is decidedly not stock. It's custom Nintendo Silicon, and it's broken into two halves. There's the RSP, which is reality signal processor, and then the RDP, which is the reality display processor. And basically, the RSP is another MIPS CPU all to itself, except it has a vector coprocessor, so it does like all your SIMD operations basically. And then the RDP, the reality display processor, does rasterization and shading and texturing and stuff based on a set of commands that are passed in by the RSP over their link that they have internally. The RCP is actually really weird because all of the RAM is also hanging off of it. So like there's the programmable part, which is the RSP. There's the quasi-fixed function part, which is the RDP. And then there's also a huge chunk of silicon dedicated to basically being a North Bridge. So it's a very weird little chip. But yeah, so that's what it is. The RDP is the display part. So it starts with rasterization, then texturing, shading, etc., etc. And it's challenging because it does like slightly weird things, so it's not a good map for modern processors. What's it? The RDP. All memory access goes through. Well, okay, so this is a little bit fraught. Yes, in that the reality coprocessor is what RCP stands for, and all memory accesses go through it because it's the North Bridge. But it's not a MIPS coprocessor, so you can't access it as COP0, COP1, whatever. And while the memory access goes through it, it's not like you're writing to a CPU and then the CPU has to go talk to memory. It's just a North Bridge. It's a controller chip. So does that make sense? It's a very weird system, honestly. And it has unified memory. So all the RSP, the RDP, and the CPU all talk to the same memory, which is RDRAM. So anyway, I built MooPen because I didn't want to force you to watch me build MooPen. So I did it ahead of time, which was a good idea because it was kind of a mess. Oh, I left this breakpoint in. It's a very weird system is a good description for the few tidbits I know of the N64. Yeah, well, I mean, it is. Yeah, getting MooPen to build is fun. Yeah, so I wanted to spare you all that fun. So there you go. This is the MooPen test ROM. It just displays MooPen 64 Plus, but we're not even going to use that as our test case. We're going to use one of Peter Lemon, who is Crom in the Discord. He has RDP test ROMs, so we're going to use one of those. So rip a branch off here, Peter Lemon N64. So Peter Lemon has done a really great job of putting together a ton of test ROMs for the N64. And the one that we're going to be using is this RDP 16-bit triangle, and we're going to use fill triangle because it's the least interesting. And so our output from what we sample from this should look exactly like this, right? Red triangle, green triangle, blue triangle, white triangle. And we're just going to go ahead and download this. I'm pretty sure, yeah, so this is the actual ROM. Just copy that over. The name got updated, right? Yeah, so it does say Magic now. So the reason it's called Magic, by the way, is that the original code name for the N64, which a lot of you know, is Ultra. And in the book Cryptonomicon by Neil Stephenson, they talk about Ultra, which was the codename project for the decryption of Enigma, or no, Ultra I think is the Japanese codes, and then Magic is the the corresponding project for the Nazi codes. So that's why I named it that. Not sure that's a good reason, but that's my reason. Jeez, cat. I can't change things if your tail's in the way. Ah! So we're just going to go ahead and change this to that test ROM. Doodly-doo. What's the name of that thing anyway? Did I not just copy you there? What the hell? Ah, okay. Supposed to be right here. Copy this. Go over here. Apply. Okay. Debug. All right, so hopefully we should get our triangles now. Does anyone know how to tell Windows which monitor to open programs in by default? Okay, so this file is completely empty. Awesome. Oh, no, it's not. Okay. I wonder why it's not working, though. It's annoying. Not a great start. This whole thing is just frozen up. That's cool. Cool, cool, cool. Right-click Open With. That's what program, surely, as opposed to what folder. Ubu N64 time. Yep, we're already having problems. Hooray! All right, well, we'll just use this. That's fine. This is good. So, kitty. I don't know why this thing's so damn slow. Doesn't really seem like it ought to be. All right, there we go. So I built MooPen from source. This is running on the Rice video plugin, which is sort of the default one. I've heard it's not very good, but it doesn't really matter for our purposes. Yeah, right. So here's what we're going to do. We're going to open up Dummy Video, which does exactly the same things that the sort of nominal, that the real backends would do, except that it doesn't actually do any of them, right? and we're going to just change this function, which is process RDP list, which is the low-level command list, basically. And all we're going to do is dump out all of the commands. And so hopefully that'll work. Here we go, GFX info. So the way that this works basically is that you get passed in a GFX info on initiate graphics, and you need to store it or a reference to it. Can't stay any longer, got an essay to write. Good luck with your RDP adventures. Thank you. Have a good essay. Yes, so we're going to store a pointer to this. Oh, fair. And then we're going to, on process RDP list, you can see that it gives you the DPC start reg, end reg, current reg, status reg, etc., etc., etc. And so what we want to do is just copy everything between start and end. Won't that get freed when it goes out of scope? I don't think so, because I'm pretty sure this is itself. Yeah, maybe you're right. This is just a struct filled with pointers. All right, whatever. We only need the two, so let's just do it that way. Unsigned int pointer RDP start. Unsigned int pointer RDP end. And then we'll do RDP start equals GFX info dot start reg. Alright. Why would you case things this way? And reg. Okay. Alright, and then when we call process RDP list, all we're going to do is just copy from RDP start, RDP end to a file. And so we need a file. I wonder if that'll work in MSVC. Who knows? Nope. Alright, and then we're basically just going to do. It's been a long time since I've done file I/O in C, so let's go through some of the C I/O functions, make sure I don't call a stupid one. The spaces between function names and the parentheses are making me feel bad. Yeah, me too. It's terrible. What a bad fucking format. Yeah, I definitely don't want this. I want F right, obviously. Void pointer, size, count, etc. Why are these int pointers? That seems bad also. It's kind of strange. reading commands from that's obviously not how you print an address. I'm pretty sure there's a printf specifier for address. And then we're just going to do fwrite RDP start. Element size is going to be size of RDP start. Element count is going to be RDP end minus RDP start. And then the file is going to be file. And that'll work, probably, probably not. All right, let's just check here. Printf address specifier. P, that's right, of course it's a P. Also, that's a percentage sign. All right, let's see if this gets run in the way that I expect. Also, I'm just gonna remove the existing video plugin. Debug MooPen 64 plus video. So hopefully we get, yep, video plugin dummy. Did not specify a render callback. There will be no on-screen display. Okay, apparently we're not going to call this. Sort of annoying. Besides video output, maybe it's supposed to return something else. I don't know. Let's look at the documentation, which I did in fact open up. Just pull that over here. API. All right, so here's what we want to do. Video. Plugins. Video. There we go. Okay. So the only things that we're doing is, how do you set up a callback function? Set rendering callback. Allows the core to register a callback function that will be called by the graphics plugin. It must take a single Boolean parameter. Okay. Here we are, set rendering callback. So we've got to set that to something. Do nothing. And then we'll just say callback equals now let's see what we get. It says no video plugin attached. But it is a video plugin. What you talking about? Breakpoint will not currently be hit. The source code is from a different. Okay. So I guess we didn't build it. It's a bit weird. Hello, cat. Isn't that setting the local variable? Yeah. But it's not complaining about, oh no, it is still complaining about that. All right. Ow, 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 ow. Sharp. not actually sure how this is supposed to work because you can't like dereference it. Shouldn't it need to be a double pointer? Let's go find it somewhere else, shall we? Let's look at it in Rice. I'm assuming it's going to start down here somewhere, but who knows? Render callback. Render callback, callback. Oh, okay. I see what's happening. It looks like setting the render callback is the opposite way. Because you have this render callback item here, and then presumably something is done with that at some point. I was expecting this to be a little simpler than it turns out to be. Oh well. So allows the core. Yeah, so you know what's tripping me up is that what MooPen Plus calls the core is the opposite of what RetroArch calls a core. Because RetroArch thinks of everything as like plugins are cores, basically. So, call during core attach plugin to send info about the emulator core to the graphics plugin. This should create the rendering window. So how, I guess I could just search for that string, huh? Find where that's being called and see what I'm doing wrong. Is this the stream for the CDI emulator? Yes. It is now, as far as you know. Alright, let's see here. What are we looking at? No video plugin attached. Input plugin did not specify a render callback. There will be no on-screen. Oh, that's fine. I don't care about that. No video plugin attached. All right. Where do you get set, buddy? Plugin connect. All right. Set function pointers for required functions, blah, blah, blah. Optional functions, version info. All right, let's just breakpoint here and step through it and see where we screw up. Okay, that's not even getting called, I guess. Interesting. I'm waiting through MooPen because I want to capture the RDP display lists. And I want to just slightly modify the dummy video plugin to that end. Let's see if we hit this. Okay, so we do hit this one, which is good. We do call plugin graphics connect, so that's, oh, I see. It's because it's if plugin handle null is returning false. And so probably wherever plugin handle is set, how do we end up with dummy though? Not exactly. So basically, the RDP takes in a set of command lists, and I need a source of those command lists to how did you do that, you weird thing? I need a source of command lists to feed into my emulator, basically. And so I'm going to dump those from the from MooPen 64 Plus because I know that they can do stuff, basically. Yeah, it's just to get the data to test stuff without having everything else implemented. Exactly. This is for a detach plugin, I guess. Okay, so it's probably there. Right, so this gets called 4 times or so, and then we're in here, which is core attach plugin, and this is where we get plugin lib handle. All right, so then where is this called? That's interesting. I mean, I think the easiest thing to do here is to just break that switch statement. Yeah, so just take this one and remove this bit. Oops. Okay, it doesn't say anything about not having. Oh no, it does still say that. All right, so much for that plan. Okay, you were right. We'll just stop there and look at the call stack. So, what are you called from? SDL main? Thank you. That's cool. All right, attach plugins to core. Attach plugin map type, plugin map handle. Okay. Well, that's never going to work out because we're never going to have a handle because it's not separately loaded. So I think we do want to just hack that. We want to figure out what is going on here. Well, I mean, I guess this is fine. I changed it in the wrong spot. We want to go in here and just do that. It'll probably be bad. But it should still have this, right? Like, where did that come from? And then we just won't use this. Let's just see if this works. Would it be maybe be easier to hack in your file outputs into the non-dummy video output? Yeah, that's my next plan if this doesn't work. What? I can't do if true? What's wrong with you? Oh, it's C. That's what's wrong with it. Yeah, stop. Stop breaking, please. Continue. All right. Yep. Let's just do it your way. Add it to rice, which is what we were using previously. Rebuild that. And we want to find the display list bit. What's it called again? Process RDP list. But that's not what it's called in the header. There are infinite truths, you fool. What do you mean Booleans should have two possible values? I know, it's a novel argument, to be sure. There we go. It's process RDP list. That's what it's called. Probably. Oh, here we go. Process RDP list. Yep. Okay, so we'll go in here. Process RDP list. All right. Let's see if we can cause that to be hit, huh? All this function pointer and DLL indirection sure makes this code base easy to read. I don't even know what file I put a breakpoint in. It's got to be in here. Okay, yeah, here we go. And it is still Debug E, so that's good. Continue. Cool, you're not getting called. Awesome. How annoying. Are we even using you? Yeah, we are. Using video plugin. I wonder if it's because this is like a high level. Let me start here, because I know that's supposed to get called. Okay, so this gets called. That's good. This gets called and gets broken on, so that's a good thing. Obviously, process RDP list is not getting called. Perhaps process D list is. Okay, so yes, this is getting called, which is interesting because if I remember correctly, the description of process D-list said high-level graphics D-list not currently used. But clearly, it's currently used, so that's interesting. Gotta love up-to-date documentation, absolutely. Okay. I wonder. Never trust Nest Dev Wiki. Yes, that is true. I wonder. This doesn't really seem right to me, but I guess it could be. Current microcode map. Yeah, this is pretty much definitely going to be an HLE plugin. So let's just take a look at this one instead. This looks a lot lower level to me. Although maybe not, who knows. But so let's take a look at RTP List in this project. Process RTP List. Hey, great. Called when there is a D-list to be processed. All right. So let's take this, and we're going to go ahead and video rice.dll. We're going to build that specifically. Hopefully it now exists in here somewhere. Yep. And if we hit run, hopefully we will run into that as our plugin. Yep. Glide N64 Mark II. But nonetheless, it still does not seem to be calling this. Cool, cool, cool. I wonder if there's like an argument to tell it whether it's an LLE or an HLE process somehow. You know what? Here's what we're going to do. We're going to find it in here, in this project. Doo-doo-doo. Interesting. Okay. Weird. I wonder if there's like a config argument, like I was saying. Yeah, that's not going to be helpful. Where was the thing that I was looking at? I guess that was in the UI, actually. There's like a parse command line. Yeah, here we go. No on-screen display, full screen, windows, speed limits, resolutions, cheats, plugins, graphics. I wonder what this is supposed to be. Apparently it's only for Dynarec. Save date, test odds, da 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 da. Okay, none of that is helpful. But there was a thing about plugin commands. Parse command line plugin, there we go. See if the Glide N64 expects anything in particular. Full screen, anti-aliasing. Third phase of command line parsing. Yeah, man. Like, this really looks like it's getting called. I don't know. Or like it should be getting called, rather. Why have a mutex on a function that never gets called? RDP triangle probably gets called in RDP command table. This is all in microcode. Yeah, weird. I don't know. I'm not super clear on how to make this work. Glide 64 Mark II LLE. Maybe we want to download some other LLE plugin instead. So Glide N64 is capable of LLE. Angry Lion RDP would probably be pretty good. I don't know how you're supposed to specify. Alright, let's just download the Angry Lion RDP Plus, huh? See if we can build that. It's got an MSVC file. I'm sure there won't be any issues. Oh, sorry, buddy. Let's... Oh, it's because it's running. Can't open a new project while it's running. That makes sense. Alright, so... if we could build this, hopefully... Nope, failure. Cool. Windows SDK version not found. Installed the wrong version of the SDK. Can I change the version of the SDK? Please and thank you. Retarget solution to the one that I actually have. Oh my god, you want me to have Python? Oh, what a pain in the ass. Alright. It seems that what's happening here is, first of all, that it's hard targeted at a Windows SDK version I don't have. I should have some version. Yeah, there we go. So we should be able to change that at least. I wish my RDP worked. I also wish my RDP worked. I also wish anybody else's RDP worked. Okay, and now it thinks I need to have Python so that it can make a version file, which is what it's looking for and can't find. So maybe if we just delete that reference, it'll just work. Probably not, though. Core name, undeclared identifier. Const char pointer differs in level of indirection. Int? What? That doesn't make sense. That must be old. Cannot open file core.lib because it's trying to do this thing during its run. So hopefully we can figure out how to tell it to stop doing that. There we go. Goodbye, Python. Build. There we go. All right, so that worked. Now, if we can maybe, where's our process D list? Is too high level. Oh, maybe that's the problem, is that I have an HLE RSP plugin. And that's why it's not calling the LLE routines. Okay, that would make some sense. So with that additional knowledge, maybe let's go back to MooPen and see if we can just modify which RSP plugin it's using. Yeah, because this is RSP HLE. So I bet that's why we're not calling those instructions. Because the RSP is supposed to chew up the commands, right? So CXD4 coming at you. Is there like a release of this that I could just download? That would make me happy. This is the source tarball. It seems like there should be Apparently they don't necessarily come pre-compiled, so let's compile this guy as well then, huh? So is your initial plan to write a module DLL for MooPen for graphics? Yeah, I guess so. What I'm not super interested in the MooPen part of it, right? Like all this extra stuff around it. What I really am going to write is like just a triangle renderer based on the RDP command set. And then at that point, I'll decide whether I feel like it's a good use of time to integrate it into MooPen or whether I want to move on with the rest of my emulator. I expect that the latter is what I will want to do, but I don't know, maybe somebody else will think it's worth packaging or something, but I'm just not particularly interested in contributing to MooPen in that way. Let's see if this builds. Probably not, but maybe. Hey, it built. Awesome. Okay. So now if we copy RSPCXD4, we'll go ahead and get that. Into our UI console, projects, Visual Studio, debug, and then we'll do the same thing with, well, actually maybe we'll just try with just that first. UI console, projects, Visual Studio, debug, RSPHLE.dll. And then if we run it, let's see what we get. So we did find RSPCXD4, so that's good. And hey, there we go. Now we're calling process RTP list. Should probably remove that. Whoa. Interesting. Possibly the Glide N64 LLE stuff doesn't work very well, but at least it's getting called, so that's good. That's progress. Yeah, okay. I have absolutely no idea what this is talking about, so who cares? Oh, this is a miscellaneous file. So this is in the, where are you? Oh, okay. So this is actually an RSP bug, which is interesting. I wonder if it will be fixed if I use the other version, or if like there's more stuff missing that I didn't copy over. Let's just check the output folder real quick. You know, I did a bunch of pre-work so that this video wouldn't just be, or this stream rather, wouldn't just be me trying to debug build problems, but you know, it do be like that sometimes. Alright, so let's build this again. Don't care about Zomar, just care about MooPen. Okay. MooPen. Or no, just Angry Lion. MSVC. Debug. Video Angry Lion to N64 Plus UI console projects Visual Studio debug. Okay, and then we're going to go ahead and get rid of the glide one. Video glide N64 Mark2.dll. And then we'll try and run it and see if it dies again. Oh, it failed to load the Angry Lion DLL. Interesting. I wonder why that happened. Oh, I bet it's yeah, that's why it's built as 64-bit. So we got to change that. And then that should cause things to work better. Platform, switch to Win32. Hopefully that's good enough and it doesn't depend on some other weird thing. I think that's probably it. x86. Build. Okay, and you still tried to run make version.py for no good reason. Unresolved external symbol. Library machine type x64. Okay, so let's change this one also. Or maybe we just need to clean it. And it's not building because it's got this Python thing again. Apply, okay. Build. Build. Okay. So that looks better. Now let's copy Angry Lion, MSVC, build, debug, DLL, to debug. And let's try it now. It's still going to crash? Probably. Yep. Awesome. Sure wish I knew why that was happening. Maybe I need to check out some other version. Where's my, here we go, C64. Oh, maybe it's in the wrong Windows SDK version? I don't know why that would matter. but it could. Oh, I forgot to close this debug sesh. You guys can't hear him, but my cat is purring incredibly loudly. Chill, cat. Okay, cat. Also, by the way, Diana, if you're here, why don't you show them the emote that you made? It's not in yet? Yeah, it is. I admittedly don't know very much about how this works, but I did put it in the thing. Oh, still hitting this error, huh? What if I hit continue? Stop breaking. Just let it roll. Yeah, I should have at least one. I'm not really sure how that works. Anyway, you think Twitch needs to approve it? I suppose that's possible. Yes, it does say pending on it. Alright, never mind. I lied. I lied to you all. Jeez. Cat just sat on my headphone cord and yanked my face down. Pay attention to me. Whoa. Hey, Waggle versus one fluffy boy. Yeah, no kidding. I'm losing. I wonder if this is like broken because it's halfway through a cycle. Maybe I should have downloaded the release. Ow! No with the claws. Ouch. The other cat is jealous. Okay. Jeez. Okay. Goodbye. R-CXF MooPen 64 plus RSP CXC4. This is going to be my last attempt to do this. With the external plugins in this way, I think. I might just, well, I don't really know what the alternative is, to be perfectly honest. Let's just hope this works. Okay. yes. So RSP source Visual Studio. UI console projects Visual Studio debug. Please don't explode. Hey, that looks like progress. The screen turned from white to black. It's still incredibly slow, but maybe it works. Here's my extremely slow black screen. It's not necessarily clear, maybe, that it actually is working, but it seems like some amount of progress anyway. Using RSP plugin static interpreter. Is that what that's supposed to be called? Oh, this is the wrong folder, obviously. Yep, that's what it's called, alright. So I guess that works. Version is 1.2. Okay. Oh, hey, it is running. It's just running amazingly slowly, and you can't actually see it, and it won't respond to any input. So there you go. This probably has a lot to do with the fact that I built it in debug mode, and therefore it's even more incredibly slow than it might be otherwise. So what if we don't do that? Hey, I broke everything. Cool. Forgot I made a bunch of changes. It's probably not this part that matters anyway. But okay, it's running. That's good. All right, progress. Now we need to look at this thing here. And let's copy our changes from the dummy bit of here. So where'd you go, dummy video? There you are. So we're going to go ahead and copy this junk. Stick it right here. Or no, stick it above initialized graphics. See, they are just saving a pointer to it. Or they're just, I guess they're copying it, probably is what that is. Anyway. Which means we don't need to do these. We do still need to open the file. And then in process RTP list, this is obviously the wrong one. Just gonna stick it right here. And instead of RDP start, we got gfx.dpc start reg. DPC end reg. Oh, and then I just figured out just now while I was talking why it is the way that it is. And it's because in the API, if we look at the plugin has access to the RAM directly. So we probably are going to want to look at Right, because there's the RDRAM pointer, and then there's these integers. So instead of being direct pointers, they're just sizes. So we're going to go ahead and dereference those, not make them pointers, them hex values, although, again, I'm not very good at whatchamacallit. Start reg. And then this is going to be size of gfx.dram. And then the count is, of course, going to be gfx.dpc_end_reg minus gfx.dpc_start_reg, and then file. Okay. So let's build that. Move it over. Oh, you know what? I should probably build it as release if I can. Let's see if that'll even work. Okay, well, let's try to run Python again, but that's okay. We can just get rid of that. Because it's very, very slow as it is, and building it in a debug mode is only going to make that worse. Okay. Angry Lion, MSVC build release star.dll to UI console. Whoa, hey, look at that, we're reading commands. I forgot to put a new line at the end of the print statement. So many commands. All right. Let's start by doing that. Thank you. I have wrestled MooPen and friends into submission. At least to some extent. That's interesting. Power bombed MooPen into oblivion. Yeah, something like that. Okay. So obviously this is incredibly slow. I'm going to go ahead and turn off the logging statement, which I'm sure doesn't help. I'll also see if I can build CXD4 as release, which hopefully I can because it just built. It was like incredibly easy. Yep. Then RSP, CXD, source, projects, Visual Studio, debug, star.dll. Hi, kitty. He's a very good cat, but boy, does he want attention suddenly. Oh, it's because it's almost 5 o'clock, which means it's almost dinner time. Oh, guess I didn't build it. Or no, I didn't recopy it, that's why. One more again. 1 hour, 10 minutes, 57 seconds. Oh yeah, we got a bot. I forgot to mention. I don't know if anyone cares, but we have a bot now. It will tell you the uptime. It will tell you my YouTube, Discord, etc. There's a list of commands right there. Slowly, I am transitioning into a real-ass streamer. All right, I'm going to let this run. Actually, you know what I'm going to do is I'm going to feed the cat. I'm going to take a little break for just a second. I'm going to feed the cat. And then I'm going to come back, and this will have actually drawn something to the screen, and then we'll have our commands sampled, and we can stop messing around with this junk. And we can get on to the cool stuff, or at least what I think is the cool stuff, although it'll probably still be mostly infrastructural today. But yeah, that's what I'm going to do. Take a little break. I'll be right back, probably 5 minutes. Got to feed cats. All right, fed cats. This guy's still kind of chewing along, but I want to see how big the file has gotten. Project, Super Studio, debug. Actually, it's probably in here, right? Maybe not. Nope, it's in there. Du-H RTP List stop in. Okay, that's not very big. 3.6 megabytes. Oh, right, okay. Yeah, so we'll just let this keep running for a little while in the background, but in the meantime, the next bit is to go ahead and so we've got this existing repository, which I'm just going to go ahead and actually just do git add -u. git commit -m whip commit. Not sure what's going on because I haven't, like, let's see when my last commit was. July, so it's been a while. So what I'm going to do is, there's a way to do an orphan branch in Git. I always forget how that works. Apparently you just pass orphan. So git checkout orphan stream. And then git reset hard head. Oh, okay, there's apparently no head. Git rm cached star -r cached git status. Okay. All right. So this is a totally new repository. All that old stuff will still exist. We just have this new branch, and we're going to do initial commit of new stream branch, git push -u origin stream. So all of this stuff will be available on my GitHub, hopefully in something closer to real time than it was for the NES stream. So now, we start up our cargo business, and the first thing that we're going to do is we're going to write a nice little parser for RDP commands. And we're going to use Rust's discriminated enums to do that. The first and easiest version is the no-op. One can find the RDP commands online, ultra64.ca. I have heard that some elements of this document are incorrect, but we'll figure that out as we go. So basically, it's a set of commands, each of which is aligned on 64 bits, and they either are standalone commands like these that I'm scrolling through, or when it's a triangle command, they're made up of multiples, right? So there's 4 edge coefficients, potentially 4 shade coefficients, 4 texture coefficients, and 4 z-buffer coefficients. And those are basically just like commands one after another. So that's why edge coefficients here just says command. It doesn't have an opcode. And then when we look at like shade coefficients, there is no opcode because it's already specified by what you gave to edge coefficients. So we're going to the first thing that we're going to do is just a filled rectangle, a non-shaded, or triangle rather, a non-shaded triangle right here, command 08. That's the first thing we're going to try to get working. But in the meantime, I'm going to just implement no-op to kind of show the process by which I intend for this to work, because no-op is command code 0, and obviously it does nothing, so it's very easy to deal with. Basically what we're going to do is we're going to implement this try into trait just for fun. Or do you probably want to implement try from instead, actually, right? So yeah. So try from U64 for RDP command. And then the trait that we need is try from value, return result, self error. And we'll start with just a static string. This is obviously not a good way to do this, but I'm going to do it anyway. Well, actually, it's a fine way to do it. So basically, we're going to take in the value, and we're going to do... we just basically need the top byte of this, so we're just going to right-shift it by what is that, 56? And then as you wait. So according to this document, we're just taking the top byte here. And then, oops, we're going to use another nice Rust feature. Holy cow, stop. Okay, here we go. Which is match. And so this just basically makes us exhaustively match on all 8-byte values. Although I probably should shorten it because it looks like the command is only bit 61. So that means that we have a 6-bit opcode. So let's do that. As, or no, and 0x30f. And if we have 0x00, then we're going to return a no-op. And that's just like how it's going to work. Unfortunately, we can do this. Parse no-op. Let command equal 0u64 dot try into dot unwrap. And if that works, then we want to do assert equal command, and we probably are going to need to derive partial equals and debug. How we doing over here, buddy? Still running along? Yep. Oh, right. I always forget you have to do this. Oops. So because the tests are in a separate module, I have to import that. That's fair. Convert try from. So because the tests are in a separate module, mod tests right here, which is not compiled during tests, which is config test right here, then I need to say I want to use all the stuff from the parent so that I don't have to qualify everything with, you know, where it is in the hierarchy. I keep doing that. Gotta use that again. Try from, try into. Whoops. Go. Oh yeah, I expected command result. So what we want to do instead is return OK of this, and then error with a string, which is invalid opcode. Oh, it's not error, it's error. I always forget what is short and what is not. Okay, so there we go. And now we pass our test. So that means we took this 0, we tried to parse it into an RDP command, we asserted that it was successful, and then we asserted that it was a no-op. And so that worked out great. And in the meantime, if it takes a second to render, we've managed to draw some text, and we're up to 12 megabytes of commands. So I think that's good enough for a test sample. So let's go ahead and quit that. And we'll just go ahead and copy that stuff to the magic directory. And now do All right, so now we've got this for our test data. And we can or no, it actually wants to be here. Okay, so now another nice thing with Rust is that you can have what are called integration tests. And so what we want to do is go ahead and create one of those. And we'll just go ahead and do parse example list. And so this is where we're going to read in that list, and we're just going to crunch through it. And we'll blow up when we hit unimplemented commands for now. Later on, we'll do something a little more interesting, probably. So the first thing that we want to do is open the file, which is standard FS file. RTP list.bin question mark. I feel like there's a thing that tells you that I want to open this as a binary. Right, open options is probably what we want. All right, and so this will let us modify various things. Specifically, we want to be able to say that we want to read it as binary, which I think is probably in here somewhere. Maybe not. All right, well, it must be fine then. And this won't work because, yeah, we'll just expect couldn't find input file. And then going back, read to bytes. Yeah, that's not actually how that works, is that? Commands is a vector of U8, I guess. Actually, we probably want to use byte order for this. So there's a really convenient wrapper crate, a Rust crate, which does endianness conversions, basically. And you can just read U64s directly out of the thing. And then hopefully you don't need to mess around too much. So let's do that. This is one of the nice things about Rust, but also one of the dangers of Rust, is that there's basically a crate for most things that one could conceivably want to do. And if you go too crazy, you can end up importing a million crates, and then you end up with really long build times and things like that. So, is there any way to get the length of a file? I feel like there should be. but maybe there's not. You can set the length. Oh, maybe it's in the metadata. Yep. Divided by 8 should give us the right length here. Actually, let's break that out because we're going to want it again. Commands. And then what we want to do here is read U64 into, and then we also want to do commands dot resize width. I forget how this works, but I think it's just like this, and then num commands. So that pre-allocates the space basically, and then when we call this, hopefully we get the right thing. See how badly I screwed this up. Expected a fun mute closure. Found U64. Okay, so I did this in the wrong order. That's fine. Expected U size. Found U64. Ugh. Fine. Try into unwrap. All right. So what's happening here is that Rust is complaining because I'm mixing integer types. There's uSize, which is supposed to be used for the size of things, but the file metadata, inexplicably, is returning a U64, I guess because it's the biggest integer type that it thought was guaranteed to make sense. So then I have to tell it, like, no, this needs to be a uSize so that I can do all this other junk. All right, and then I need to do big endian. I have to specify the endianness, which is, of course, the whole point of this crate, which means I need to use it. I am assuming that it's big endian, given that everything else in the N64 is big endian. So what happened there is that I'm trying to mutate that. I'm trying to read commands into it, but then I didn't make it mutable. So in Rust, you have to be explicit about what you allow to mutate and what you don't allow to mutate. There we go. Not enough commands. Yes, there is an asterisk to that with interior immutability, which I did use in my NES emulator because, again, I did the wrong thing on purpose. But yeah, I mean, there's a bunch of asterisks to that. There's interior mutability with cell and ref cell and unsafe cell. There's like the atomics. There's a bunch of caveats, but ARC and RC are kind of weird, although I think you do have to actually deal with mutability there. Right, so this works. So now we're going to do for command in commands, let command, or if let command equal command try into line got command else oh, you know what? It's because I'm not importing stuff, although it's probably still mad at me. Yeah, okay, so I need RDP command, enum RDP command. I'm not actually sure where the type annotation is supposed to go with an if let. Oh, maybe it wants it to be here. I mean, okay, I was wondering. I think I might need to extern create magic. I always forget how this works for integration tests. You mean unexpected type argument? That seems like a reasonable type argument. Oh, it's because it's private. That's why none of this has been working. Duh. Okay. And then we don't need this. But it still says unexpected type argument, which surprises me. You'd think that would work. All right, fine. Just do it like this. Command option. Oh, expected two type arguments. Okay. There we go. And then if we do no capture, so we can actually see what's happening. There we go. We got all these various commands. Some of them are no ops, some of them are not no ops, and we don't know what to do with them. So there we go. Now all we need to do is go through and implement all the other ones that we care about, which currently is just going to be the fill triangle one and its attendant bits. So, where are we? All right, edge coefficients. This is the one that we want. This is the one we want. Woo, ooh, ooh. All right. So fill triangle is going to have a bunch of coefficients, each of which are what? Okay, so we got left major flag is just a bool. Number of bitmaps -1 is 3 bits, looks like. Tile descriptor is 3 bits. But the coordinates are 32 to 45. That's 13 bits, I think. Yeah, 0 to 13, so 14 bits. And then these guys are each 16 bits. All these fraction things, all these guys. So it looks like we'll probably just make all of these as U16s. Are these all the same in terms of like... Yeah, pretty much. Okay. YL, YM, YH, XL. So these, it looks like, are basically fixed point, 32-bit fixed point numbers. You can kind of represent fractional numbers in 2 ways. You can store the integer part and the fractional part in a fixed point format like this, or you can store a floating point format, which is, IEEE. And the advantage of the floating point format is it's much more dynamic range, but the fixed point formats, it's not that they're more precise, but you have more control over the precision. And you don't get weird things where, like, you subtract very close together numbers and you get a bizarre result. Alright, so we're going to make a struct for edge coefficients, which is going to have bool left major, or no, bool right major. That's not how that works. Level will be a U8, tile will be a U8. Yeah, we'll just use the names that they're given here because I don't want to come up with new names. dx, l, dy, frac, u16. These are probably not the best representation for this right now, but we'll eventually go back and either clean it up or we'll implement useful functionality on top of it. But for now, what we need to do is to be able to just create the thing. So we're going to match on our command byte, which we decided was 08, sorry. So this is an OK, RDP command, fill triangle, except that it needs an edge coefficients structure to go inside of it. So we'll write that. But that's probably going to take us more than 1 line of code. So we'll make a block here. And now we'll basically are just going to parse these out of the next, what is that, 4? 3, the next 3. All right. So first we'll parse the first byte, or the first 64 bits. Sorry, distraction. Okay. So first we're going to parse these bits out. Should be relatively easy. Let right major equal. I made functions for the coefficients so it doesn't take up 100 plus lines. Yeah, I'm going to do that too. I lost my train of thought. I'll get it. Oh, you know what? This try from thing, which I always knew was not maybe the best thing in the world, is not going to work. At least not as written. I mean, it's fine, but it just means I can only parse these starter stuff and not the rest of it, but that's okay. 0x, what would that be? 0, 8, 0, 0, 0, 0, 0, 0. That's only 32 bits. It's greater than 0. Right shifted by 32 as U16. Actually, we should AND it first because there's a bunch of unused bits in there. This is how long? 14 bits? Yeah, so that's 3FFF. Actually, maybe we should do the ampersand afterwards. And then this one is just right shift 16. And then what's left? YH is just no shift at all. This is YM, this is YH. But yeah, this isn't gonna work super duper well because we're gonna want to parse out the whole thing. So probably this is a bad way to do it. What we should do instead is model something after these read U8 methods. Okay, yeah, let's do that. Trait read RDP commands. Fun read command from an mute self, return a result RDP command. Oops, too much deleting. Stick it right here. Let's look at the source code for this, just to see how it's done. I think I pretty much get it. Yeah, so you just implement it for IO read, and then it can be used for anything with IO read, which is great. And IO read will already come with its own error type, I think, so shouldn't have to worry about that too much. It's good. Easy enough. Okay. So instead of doing what we were doing before, we're just going to take this exact same bits here, get rid of the try from call, get rid of this implementation. All our tests fail now, which is fine. And then just do let value equal self dot read u64. Question mark. And that should build, hopefully. Doesn't, because I didn't close some parentheses somewhere. Yep. Let's just comment this bit out. Oh, I guess it would just be read, because I imported it all the way. I thought there was like a self error. Okay. Oh, it's because there's an IO result. So let's, yeah. And then we'll do IO result. Oops. Kitty, 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 kitty. No method named read view 64 found for the type self. Oh, it's because I'm not using, okay, yeah. Do. What's up with standard IO error? IO error, new error kind, whatever that is. Permission not connect your views, add or in use, blah, 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 invalid input. This needs an extra colon. Oh, right, you still need air. Go. Okay, good. Now it builds. Obviously, it's not going to work. So what we need now is to do is that going to work? Probably not. Let's see if it runs. Expected enum, standard convert, infallible, found answer. What? Oh, I guess it's because it's not borrowed. Oh, because I'm still calling. Wait, hang on. Oh, it's yelling at me because this is config test, and so now it's trying to build this. Yeah. Okay. Fix later. Rust, read from slice. I know there's a way to do this. I think we probably want buff read or something like that. No, that's not it. Do. I guess they're just implementing read on something. Sort of annoying. I bet a whatchamacallit, vector would work. So let's just do that. I guess not. That's sort of irritating. What is read implemented for? File empty repeat standard in. Blah, 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 blah. Not much, which is interesting. Oh, it is. It's implemented for a U8 slice, which I thought I had. Oh, only U8 slices, not U64 slices. That's why. That makes sense. All right, there we go. What is your problem? What is your problem, buddy? It's very annoying. I feel like this should work. Note that reading updates the slice to point to the yet unread part. The slice will be empty. I bet I need it to be mutable. No, that doesn't really make sense. Fine. Be that way. I don't understand why I can't get this to work, but I cannot convince myself that it is okay to do it this way. I really would like to have a reader of some sort. Maybe I need to like make a read from the buffer or something. I wonder if that will work. Yeah. Standard IO read is not implemented. The following implementations were found for Oh, I know what I'm doing wrong. I didn't add the actual blanket implementation, probably. Right. So this is what I'm missing. Impl R IO read plus maybe sized read RDP commands for R. In a young girl's heart. I already talked about why it's named Magic. It's a World War II reference. The original code name for the N64 was Ultra, which was the project to decode, I think, the Japanese codes in World War II by the Americans. And then Magic was the corresponding British project to decode the Nazi codes. So that's why it's called Magic. Also, I just think it's a good name. Helps if you close your curly braces. There we go. Now, just for fun, let's go ahead and make this something else so that the test fails. Hey, look, the test failed. That's good. It's always important to write negative tests. In fact, let's just go ahead and make that a permanent test. I forget how to do should panic, but I don't actually need to, so that's fine. This is not a good test because I will have to add every enum discriminant. However, one nice thing about Rust is that it will make me add every enum discriminant as I add them. It won't compile, right? Like if I go up here, or well, I guess I have an underscore, and so in that case it will fail. But I mean, I guess this will actually just fail on the unwrap, right? Right, so what you want to do is remove that and then do assert command dot is error. Oh, and this needs to be a result. There we go. And so now we have tests. Hooray! We should probably fix this one. All sorts of things don't work now. We do still want to derive debug, because why wouldn't we? Rust has two methods of formatting things when you try to print them. One is debug and one is display. You should basically always derive debug. I'm not totally sure why it's not just a thing that just happens automatically, but it's not. Okay, so this probably would work, except that you can't get a reader from an array of U64s. So instead, what we will do is command dot as big endian bytes or whatever it's called. To BE bytes. This needs to be a public trait. There we go. The method read command exists, but the following trait bounds were not satisfied. Alright, let's just require it to become that thing, and then I won't have to deal with this. Obviously, this is going to be wrong. Expected reference found, IO error. Right, because this is not right anymore. It's going to be an IO result. Needs to be mutable. There we go. And then parse example list, no capture. Look at all our unknowns. Woohoo! Okay, and now we can actually implement the fill triangle parsing for the edge coefficient, and then hopefully we'll be basically good at that point for today. Maybe do a little bit more restructuring. But yeah, so this stream was mostly just like infrastructural junk. But that's what you got to do when you start a new project. There's a lot of infrastructure plumbing. Next week next time we should be able to actually try to draw some of these triangles that we're parsing out of this thing, and that'll be fun. Okay, so I mean, I guess that's not actually how that's going to work. Let data equal, or yeah, okay, data self.read U64 big endian question mark. Oh, I don't know why I ended up with only one of the 4 rows put in here. HM. There we go. Value, right shift 48 as U16. Frac is 32. DXLDY. DXLDY frac. 1, 2. Gonna make it valwho and het, but that's okay. Just fix those. It's a better way to do that, I'm sure, but. And then same here. Actually, you know what? It'll be easier if we start from here. HMG. And then we're going to return OK, edge coefficients, right major, YL, YM. I mean, basically all of these things. Just copy them. Delete stuff. Easier. Colon dot star comma with just comma. Hey, look at all these problems. It's because I didn't put RTP command fill triangle here. Oh, and we're missing level and tile, which I guess I didn't parse out for some reason. Level, value, right shift by 51 as U8 and 0x03. Wait, no, 7. And then this is the same, except it's tile, which is also 3, but it starts from 48. And then we need to put them in down here. Level, tile. Boom, okay. And if we do this again, we should start seeing filled triangles, hopefully. Maybe I should only print it if see if we get any. Cool, we got 0 of them. Which means either I'm parsing it wrong or they just legitimately don't exist in the source. Either of which would be kind of a bummer because that was what we were hoping to use as our source for this whole thing. 0x08 seems correct to me based on this document. It's always possible the document is wrong. But it's equally possible that we just have other kinds of triangles. So there's shade, texture, shade and texture. Let's see if we can run into a shade triangle. Nope. Texture. We should definitely have some kind of triangle in this output. Hopefully. Nine. Nope. D. Nope. B. Nope. F. Nope. Okay, so there's apparently no triangles at all. That's strange. There's lots of no-ops, but no triangles, huh? Alright. Let's just dump all of this to RTP list.log. Forced me to start working on my Rust RISC-V emu again. Hope you're happy. I am happy. I object to the framing of forced me to, but other than that, what is an FF command? That's got to be the set address, right? I wonder if this is backwards. No, that doesn't make sense. I guess those 2 bits are like really ignored then, huh? Because these seem wrong. BC, I guess, would be... I don't even know what that would turn out to be. Something C. Interesting. Well, oh no, okay, so here's 3C, so it's probably that. Or no, that's not how B works. Yeah, it is. Okay. Interesting. I wonder what those extra bits are supposed to be for. Somebody who's done this sort of thing before should tell me at some point. So are they rendering rectangles or something instead? Let's see here. Fog color. Key RGB. Syncs and stuff. And there's no op. Where's the command list from? It's I made a dummy plugin basically for MooPen, and I ran it and then dumped the RDP commands that it received to a file. But apparently that didn't work out. So I was trying originally to run Crom's test ROM. It didn't seem to work out, which surprised me. But at that time, lots of stuff was broken, so maybe we'll just try it again. That's what I'm doing right now. What game? It was from the MooPen demo ROM. Fill rectangle would be 36, which does occur. So maybe that's what it was using. Kind of weird, but texture rectangle also happens. Texture rectangle flip, whatever that's about. Yeah, so it must just be drawing with rectangles, which is lame. time is it? 6 o'clock. Okay. Well, I feel like I basically accomplished what I wanted to do today in terms of getting the MooPen thing running and in terms of getting started on the command list parsing. I think I'm going to call it for tonight. I may do some more MooPen fiddling off stream just to get a better set of commands to run from. I don't think that's going to be terribly interesting. It'll be a lot of me staring at blank SDL screens. So I'll probably do that off stream, but I'm definitely going to be back next weekend. And I may be back in the interim if I'm feeling inspired. So thank you all for coming by. I appreciate it. I saw that we got up to like 30 some odd viewers, which is incredible for something like this that's just getting started. So I really appreciate everybody coming by. I hope you have a great night, and I'll see you next weekend, if not before.